Okay, do. C'est bon? Okay. So, gonna start the tutorial. I wasn't sure how many people would participate and what would be the level of everyone participating in this tutorial. So I actually split it in 4. The first section is going to be a refresher or an introduction, depending on where you're at, on the basic plots. So we have the line plots. We'll see some attribute for the scatter plot, and then the histogram. If you know how to plot these 3 types of graph, you should be good for general graph plotting. And then we'll jump to plot attributes, so how you can modify, for example, title, axis labels, the color and the styles of your plots, and then also how we can add horizontal and vertical lines, which I found to be very helpful when you want to demonstrate some values, and then some stuff on legends. And then the third section is going to be figure and subplots. So it's basically a big example of a subplot. So how to put various graph in one figures. And then if we have time, we can look at a more general example with the iris dataset, which is a dataset on flowers attributes and how you can plot them together, and then we can apply some PCA to it. So we can see which type of attribute of the flower seems to plot together. So that's pretty much what we'll see today. Don't hesitate to stop me and ask questions. If it's too basic, tell me, we'll go to another section. The aim of this tutorial is that it's quite dynamic, so we can code at the same time. I shared the notebook also if you want to do it at the same time, if you have a Jupyter Notebook installed. So first thing first, make sure you have the right version of Python. Do you guys have any feedback, or is it just me? You don't? Okay, so vous êtes correct? Parfait, c'est ça le plus important. C'est ça le plus important. So I'm using Python 3. If you're using Python 2.7, it should be good, but you might have some errors when it comes to the data format, but it shouldn't be too much of a hassle to debug it. For the Matplotlib library, you need to import it. Depending on which system you're working, you might have to also install it. The easiest way to do it is when you have a Linux or Mac OS, it's to generate a virtual environment and then pip install 3 the package. Make sure you also have the une erreur. I'm gonna make a lot of an error. It's not MTL, it's MPL. Make sure you have the latest. I'm not even sure that's the latest version, but at least have the Matplotlib 3. I think they are at 3.27 right now. But the general thing is there. Perfect. So before going any further, I'm going to import some library to help us generate synthetic data, because I'm not using real data except for the iris dataset. So I'm using NumPy and random. I'm not sure if I'm using random. Let's see. We're gonna leave it there. So let's jump to basic plots. I sometimes put a small bit of information above the various cells, and then I also often link to the best resource site if you want to go deeper into plotting this kind of function. So when we use a line plot, it's usually to visualize relationship functions. So when x equal to a function of x. To do the example, I'm using the sine and cos, sinus and cosinus function. So just going to generate some values. And then if we want to plot these functions, we're going to use the plot function here. It's very simple. You give it the X values and then the Y values. It can either be a list or an array or a list of lists. And that sometimes it can break. And then you have a bunch of optional arguments that you can use. If we do the very simple function, you're going to get this sort of graph with everything set to default except the values. If you want to see the graph you just generate, use the plt show function. When you're in a notebook, it's going to print underneath your cells. If you're working in a .py file and then you run that file into your terminal, then you're going to get a pop-up with the graph. Otherwise, you can save the plot using the plt save fig function and give it the name of your the plot you want to save. But sometimes it's an hassle to go back and forth between both instances. So that's the basic plot. Everyone been doing that so far? Yes. If we want to see some of the arguments that we can use for line plots, we're going to generate two new data sets, which are shift of the sinus and cosinus function. And some arguments that are interesting in using are the line style argument and then line width arguments. So when you use the plot, you always have your X and your Y. And then if you define the line style, you can have a bunch of stylish lines, which can be useful if you don't always put legend or if you want one line to pop against the other one. So what's interesting here is also we notice that the colors are set by default, and the colors are specific to each instance that we add to the plot. We can have a solid line. We can also have a dash line, a dash dot line, which is the big green one. And then finally, we also have the dot here, which is the red one. The line width is going to be the thickness of your line. By default, it's 2. So if you switch between 1 and 2, which is these 2 instances, the difference is quite very, very small. So if you want to have a bigger impact, then you can go up to 3 here. And you see it's the difference is more drastic. When you have a smooth line, you don't necessarily want to put markers for each of your data points, so as we did here. But if you have a more sparse data point and you want to connect them with the lines, but you would also like to see the data point themselves, you can add the argument marker, which is going to be the little symbol for each of your data point. I ask for a marker. Oh, someone is writing on the. I ask for the marker to be a dot. So now we have the our various data points that are connected by a line, but then they're also represented by a dot. If we get rid of this argument, just going to get the very simple. It's generated randomly, so it's going to change every time. But sometimes it can be very useful to add the marker, and you'll see later on that there is a bunch of different markers that it can be used. So for instance, now we have a small star. Yay. Do you have a question for the line plot? It's pretty straightforward, so that's
a question.
Yes. T'as une question?
No, no question.
Oh, no. Okay, no question. I'm like, I have a question, like, yes.
No.
Perfect. Let's jump to scatterplot. So scatterplot, there is 2 main ways to draw them with Matplotlib. The first one is to still be using the plot function as in the line, but instead of having a line style, we'll define it to only be markers. So we're going to say draw our data point, but don't connect them. And the other way is by using the scatter function, where it's similar to the plot one, except there will never be a line in between them. The advantage of using the plot function is that it's way faster when the the markers and the colors stay the same. So if you just want to plot it very fast to see what your data look like, then you can use this one. But if you want to do a more exhaustive figures of a scatter plot for a publication or a paper, then I would suggest you use a scatter plot to do that. So generating a bunch of random Gaussian data set here. And we'll try to, in the first, premièrement, we'll try to do it using our plot function. So I still have here all of my X value and the Y value, and then I say I want them to be dot instead of line. And what's interesting here is that our data are, it's a list of lists. So it's, if I print it, can I print it? Sorry. Aha. If we look at the format of our data set, it's a bunch of arrays within a array. So when you use, remove that, when you use the plot function here, it's going to plot every single point as its own data set. So what we did here, we actually had 3 data sets, which is lost when we use the plot function. If we go and use the scatter function, so again, I give it the list of X values and then the list of the Y values, it's going to flatten our 2D list, in which case everything is considered to be one big data set. So how do we do it to get our 3 little blobs of data set? One way to do it is we could use a for loops. So he will gonna say for I in range of the length of our X scatter data, we're gonna ask it to plot the scatter of these individual distribution. And in that case, we get our 3 distinct blobs. The colors, again, are set by default. A useful argument is the alpha argument, which is a way to control the transparency of your markers. So the max value is 1, in which case, if you have a lot of data and they are superimposed, then you might lose some of that data. And if you tone it down to, let's say, I like 7, then there's some sort of transparency and you can see if there's an agglomeration of various data points together. By default, we use the dot marker, but there exists a bunch of options. So this is the exhaustive list of marker that you can use. Don't learn them by heart. You can find it on the internet. If you want to specify which marker to use, you just add the marker argument here. And then you can also play with the size of the marker. By default, it's size 25, I think. So here I doubled the size. And for instance, here, what I did is I generated a list of X values, which is the same as the Y. So I'm going to get a diagonal. And what we want to do is that each point of that diagonal, I want it to have a different marker. So I can, again, use a for loop and then plot that single point for a specific marker here. Oh, I did not compile that cell. No, should work. Hey, so we see that there is a bunch of marker style that you can use. And then the color again are defined by default. Is there any question for the scatter plots? Nope, pretty straightforward. You've used Matplotlib before, right? Yeah, good. The last base plot that I want to show you is the histogram one, which is very useful to plot distribution. So let's say here that I have a data set of 5 randomly generated Gaussian distributions. So they have various mu and sigma value. They're generated randomly. And what we want to do is get the histogram of each of it, the individual distribution. If I use the hist function of Matplotlib and just give it the list of the various distribution values, I'm gonna get this weird graph. So why do we have this kind of graph? By default, the hist type is set to bar. So we won't have bins that span the entire set of our distribution, which can be useful if you have categorical values on the x-axis, which is not the case when we have this kind of distribution. So one way to counter that is one way we could do that is, again, use a for loop and then plot each individual distribution, in which case it gives some sort of graph that it's closer to what we would want. But then when you plot histogram, if they don't share, if you have a lot of histogram on a single figure and they don't share the same bins, it can be very hard to read, and it's messy. You won't see, well, I hope you won't see that in a paper, but you can. So what we want to do right now is have, if there's the histogram are superimposed one on top of the other, we would like them to share the same width of bin. And to do that, there's 2 ways. It's either we can set the hist type to bar stacked, or use the step-filled histogram. So let's start with the bar stacked one, which we see that the bins are shared, but it can be hard to read if we want to see the distinct distribution. If we would say that, I don't know, we just want to have a concatenation of all of distribution, we could say that the color is equal to in range of length norm test, and then we would say, oops, we would set the color to be black. And then we would get this distribution, which is equal to all the distribution together. Then the stacked, the stack approach would be great, but this is not what we want to do. So we'll use the step build one. I'm gonna remove this because I don't want it. In which case, it seems to be very similar, but if we lower the alpha, then we see that all the distribution are put on top of one another. And you see the contour of each distribution. When you have a lot of values, in our case, we have, I think, 150 per distribution, it might be useful to change the bins values. So let's say that we do the step field here. We keep the alpha to 0.7. You get a better idea of what the distribution actually looks like. And something I didn't tell you, but by default, the histogram represents accuracy count, so the number of times that number was seen in the entire distribution. But if you want to change it to a density representation, you just use the density argument here, and you set it to true. By default, it's false. And then you get the density on the y-axis. That's pretty much it for the histogram. Any question for the histogram? Nope. Good. Génial. Let's jump to plot attributes. So first thing would be to name your plot. So give it a title and then also label your axis, which is very important if you want people to understand what they're looking at. One way, not one way, but the way to do it is to use the title, the title, X label, and Y label function. They all take as input a string with the values that you want to give to your title attributes. What's interesting is that you can integrate some LaTeX notation into your title and your label. So that's very interesting when you want to put variable symbol, for example, sigma. I don't know if you want to put lower and upper values. You can also integrate some of your variable values into it with the percentage notation. Everyone, you know that, right? That's basic Python. And if you want to say, let's say if we go back to our scatter plot example, here I changed the marker for every data set to have its own marker. If I want to put a title in where I'm going to have scatter plot, and then K, it's going to be the number of not subplot, but the number of data set I'm using. And then here NK, I want it to be the number of data point for each of the data set. And I'm going to use the percentage. And then this notation is going to be LaTeX, and this one is also going to be LaTeX. And then you have it integrated into your title. And what's fun is like the LaTeX notation doesn't have this weird squiggly notation compared to when you do normal LaTeX. It's going to keep the how do we call it, the font used for your entire plot. If you want to do the X and Y label, again, it's very simple. You put your string with these functions, and then they are set here. You can add other arguments such as the color. It's going to change it. You can also change font size, or just, I think it's just size. So it's going to make it bigger. But usually I'm going to show you how to define those values in a more general way. So it's going to be applied to all of your plots here. So we've seen this kind of white boxed plot with the main color being blue, green, and orange. But there exists a bunch of styles that are available in Matplotlib. So this is a list of all the styles you can use. The one that are usually used is the ggplot one. So if you've been doing some R graphing, then it's going to look like the graph in R, but you still keep the same notation as in Matplotlib. So you don't switch from one library to another. It's just the style that you're using. The other one that are often used are the seaborn white one. I like to use the seaborn white grid because I don't like when there's a bunch of things. If you want to define a new style, you just use the style.use function with the name of that style. If you want to combine multiple styles, you can do it. You can put it into crochet, and then you give it a list of styles, and the first one in the list is going to be the first one applied, and then it goes to the second one. If there was a change in between, then it's going to apply it. It's weird, honestly. It's not the best approach to do it, because if you use seaborn white grid and then you go to, I don't know if there's a black one, seaborn dark palette, then it's going to do some weird stuff in between because they are very, very different. So I would suggest just to use one. Another thing you can do is change some attribute for your graph with the RC function. You can see here all of the things that can be changed. For example, I like to change the font size. And then when you define it here, it's going to be applied to all the new graph that are going to be generated afterward. So let's say you're working on a paper or a poster, you want your graph to have the same style across every figure, and you don't want to go back and manually change your font size for the title for each of your 20 graph. Then please use the RC function. It's very, very easy. And then if we go back to this graph, so, and we want to see how it was changed with this new style, you just take the exact same code and then you have it. It's not that most change. It's pretty much the same thing, but we could use different things. So let's say we go to the Seaborn dark palette, then you're gonna have a different one, and it's mainly the how do we call it, the color cycle that's going to change. If you take the JJ plot one, then this one usually gives you a very dark background. Yeah, so the style is completely changed from one to another. I did test them all when I first discovered that, so you find the one you prefer. There we go. And then each of the new how do you call it, plot that's going to be generated will take this type of style. Now for the color of your graph, there's many ways you can define the colors for the different element of your graph. It's good to know that each of these style have their own color cycle. So first color is going to be used by default. If you want to access those values, you can use the notation C followed by a digit. So for instance, C0 is going to be the first color of the cycle. And if you plot it, so for example, here it's when I plot a diagonal of data point with the default color. If I use the C notation here, so let's say I use C and then it's going to be equal to the value of the point, I get the exact same color. So it's just a way to access that color if you want to repeat a graph. Another way is to use the basic built-in color. You can refer them as with their name or with their, oops, here it's just an R, with their name or with their color. Don't mix blue and black. I always do that. Again, if you plot them, it's pretty much straightforward. And if you have a very precise color in mind, there exists a bunch of color names that you can use with very, very weird names. So make sure you don't have any, you don't make any défaut d'orthographe because you're going to get an error. You can also use a color code if you have a specific one that you want to use. So I don't know if you're part of a project that uses a specific color, or a company that uses a specific color, then you can define them by those values. And eventually you could even add them to a cycle that you're using so they can become your default one. You wouldn't have to define them every time you want to draw a new graph. One other thing that's very interesting when you draw a graph is the usage of a horizontal and vertical line. I find them very useful if you want to illustrate mean, median, or the bound of confidence interval. On a histogram, you can also use them to show some threshold values or a reference values that you want to reach or whatever. It's very simple to plot. You just use the AX for horizontal line. Then you give it the Y value of the line you want to draw. And then for the vertical line, it's an X. It's AXV to show the X value you want to use. They're line, so you can use the same argument as the one you use to plot line graphs. So the line style, line width, and the various color. So let's say that I want to draw the X, sorry. We have this, our scatter plot graph. Let's say I want to draw the mean line for every X value of our plot. You can do the PLT Okay, the X value is going to be vertical. The X value is going to be NP mean of this value here. Just put it here. I want the color to be the same as the scatter plot that I'm plotting. So in that case, I'm going to refer to the cycle color, which will be the same as the data set I'm using. The line width, let's set it to default, and I want the line style to be a very basic one. Général, color. So I get these mean value for each of my scatter plot. If I want to do the same thing, but with the Y mean, then I'm using the horizontal line function. I'm going to define the Y value, which is going to be on the Y scatter. The color, again, I want it to be the same. And then let's say I want to have a dash line. I get those dash line here. Another useful usage of the horizontal and vertical line is to show them on a histogram plot. In that case here, I like to put the histogram with a lower alpha, and then the line, if you use the same color, I usually put them with an alpha of 1, so there's a bigger contrast when you do them. And you could also add dash line to show the bound of your confidence interval if that's something that you're calculating. Label and legend. So we've been showing how to plot a bunch of the data set on a single plot. Usually you want to label those various data set. The first thing to do is to define the labels that you're using. I usually do it by having a list of labels. So in our case here, I am doing this histogram. So I'm going to do a list that's going to be called distribution with an integer representing each of the values. And then when I plot my histogram, I give the label argument the labels list. If I were to plot one histogram at a time, then I could define this label as a single value, not a list. And then what's very important here is that once you give it the label, you want the legend to show. So let's say I just use the legend like that. You run it, and then you have, yay, a legend in your graph. Sometimes the legend are not well placed. So one thing you can try is the lock for location argument. I like to use the best value, so it's going to try to put it in the best way it can. If this value does not work, you can use the BB box to anchor function, in which case you need to define where to put the legend. By default, it's going to be here. So you want to give it the coordinate, so that the upper corner is going to be in the right position. I like to put my my legend outside on the right side of the graph. So if I put 1 and 1 here, I'm going to ask it to be in the upper corner. If I want to make sure that it's outside, I could put 1, 2, and 1, 2, and then it's going to be up very, very high. So in that case, we would not need to put the 2. One other thing that's quite nice is to define the number of columns that you want. So sometimes you have a big list of elements. So I usually like to separate them in 2 columns. You can add a frame to your legend with frame on set to true. By default, they're not going to be one. And then there's also the, what is it? What's the face color function? Sorry, I always forgot that one. The face color argument, I like it to be set to white. In the case where I don't have any place to put it outside of my graph, then if it's inside, it's not messing with the value in the background, because sometimes when you have scatter plot and then your legend is also scatter plot and then you put it in the graph, then it seems like you added a data point to your graph. You understand what I'm saying? Yeah. So if you put a background and then a contour to your legend, it can help to distinguish both instances. But if you have place, you can put it outside. It's easier, I found. Any question about attribute?
I had a question about the RC function.
Mm-hmm.
So RC function, what did you change with the one you used?
I changed the font size. So here, if you look at the title font and at the Axis font and Axis tick font, I find it to be quite small. Like if you do a presentation and you put that in a PowerPoint, you would need to very zoom it out. So I usually like it to set it to 15. These values will be set to 15, and this one will scale for the default ratio to the axis.
So because the one before was the default one.
Yes, exactly. Okay. Exactly here. But you could also change the font style, the font family also. You can add some serif values to your font. There's a lot of things you can do.
Okay.
Figure and subplot.
I have a small question. Yeah.
Yes, hello.
Hi. If I want to add, in a bar, if I want to put specific data points and use the color for the bar and not for the data.
What do you mean the bar? Sorry.
You have the bar graphs. And yes. If you want to show specific data points in the bar graph, because I have 4 data point, and that gives me a mean bar graph.
Yeah.
And if the color, I want to make the colors different for the bar and for the data points.
Yes. So you want to, sorry, when you say bar graph, you mean like the histogram?
Yeah, like a histogram.
You would like to.
But for say each bar, if it have 5 data points.
Oh, you want to have, okay, I understand what you want to say. So, yeah, you would have, so let's say that I do x equal to 1, 2, 4, 5.
Yeah.
And then y, let's say the same thing. You would need, if you do hist and then you do x, and then you would do his type. We don't need a y, I don't know, I should set that. You would want one of these bar to be one color, then this bar be another color, then this bar another color. Is that what you're saying?
Yeah, and also if I can, in 1 or 2, say they have 5 different values, and the bar is representing as a mean of the all 5 values.
Okay. You would need to create a new list of values. So let's say we're gonna have mean x here. Or yeah, we should not do that with histogram. I know there's a I think I understand what you want to say. I'm not sure though.
Okay.
Sorry.
So the point I was trying to say, how is there a way to change the color for bar and the data points? That was a
Yes.
process.
If you do something, what could I, like that, I'm gonna get different color for each bar.
Yeah.
Doesn't get close, but if I understand what you're saying correctly, what you would like to do, it's not a histogram, but it's a count bar. So it's not a distribution, right? It's, let's say you have 5 points of value in the category 1, then you want to have the mean value of category 1, right?
Yeah.
Well, yeah, that's not a, I don't think that's a
not
histogram.
histogram. Yeah.
It's going to be a bar count. Why can I do bar? Bar should work. Sequence of scale. Because that's why it's like that. Okay.
Yeah.
So in which case you have your category here.
Mm-hmm.
Which one is E? Yes. And then let's say that mean X is the mean for each category, right?
Okay.
Like that. And then is that what you want? But you want each category to be a different color? I think, not sure, let's test it. If you give it a how do we call it, a list of color, it should work, but I'm not sure. 4, 5. Way. Something like that?
Yeah.
Okay, so it can be done like this. Does it answer your question, or I'm really not there?
So like it would be the same if I want to present what A, B, C, D, E represents, for example, like the full name.
Yes, yes. You could change that to various values. Because A, B, C, D, it's here, right?
Legend function, yeah.
And then if I want to do, I don't know, label could be the cat.
Yeah.
Mm-hmm. That's weird. I'm not sure what this is happening though. I would expect each value has a different label. No?
First say A is the black color, B is the...
Yeah, I would expect that. Why is it not giving color, the color of the bar face? I can look into it and then, yeah, come back to you on that. I'm not very familiar with the bar.
So this just change of the function from histogram to bar.
Yeah.
Thanks.
No handle, but yeah, that's it. You're welcome.
Thank you.
But I can look at in more detail if you want, and then come back like tomorrow or Friday if you have a very specific question.
Thank you.
You're welcome. Yes, so we're good with legend. For the figure and subplots, so let's take all of that away. Let's say that if we go back to our scatter example, we would like this one. We would like to have a figure with 3 columns and 3 rows, in which first row we would have all of the scatter for the individual data set, and then we would want to have also the distribution for the first and then the second component on a other row. One way to do it, there's two ways to do subplots in Matplotlib, but this is the way that I've found the most straightforward. One is to use the subplots with an S function, in which you need to first define the numbers of rows and then the number of columns you want. The fig size, share X and share Y are all optional, but I like to use them, especially the fig size. Otherwise, if I just define it like that, you get this, which can be very cramped if you have a lot of subplots to put. What I like, my rule of thumb is the height. I calculate three units for the height of each of the subplots, and then I like between 4 and 5 units for each of the width of each subplot. So in that case, we want the rows to be maybe 12, and then the height be maybe 9. It's very low, and now it's more adequate to see the graph themselves. So the first row, we want to have the scatter plot of the first and the second component from the Y scattered dataset. You need to think of the subplot as being a matrix. So if you want to access a subplot, then to access this one, you're going to go to, it's going to be subplot 0, 0. If you want to access this one, it's going to be subplot 0, 1, because we're on the first row. And then in the second column, what we do when we define the subplot is that we fix a fig argument, and then we also have this, I call it AX, but you can call it whatever you want. And this is the subplot matrix. So if I want to set the value in the first subplot, I call AX. I give it, I tell it first row, and then first column. And then I simply use any plotting function we saw. In our case, we want this one to be X scatter 0, and then we want the X, Y, sorry, 0. You're going to have this one plotted right here. We can use a for loop. So for I in range of n is defined here as the length of the scatter. We're going to define that the row is going to be always set to 0. Here, we're going to define the column as dependent on which data set we're using. So it's going to be equal to C in our case. The row here is defined by R, and the column is defined by I. And then the scatter here is also I. Oh no, not well, you can say I, but it should be, sorry, C. So let's do good practices. I have my 3 different scatter plot plotted there. Usually I like to have a different color for each of my data sets. So again, I use the cycle notation, in which case that's going to be set to 0. Exactly. And what's interesting here is that we see the axis values are quite different. But if you look just at the scatter plot, you would conclude very fast that they seem to be the same. And if you want to look if they are really the same, you're going to have to go to the axis. So sometimes it's useful to use the share X argument, meaning that here we're going to say for each row, please make the subplot to have the exact same range of X axis. And it's very useful when you want to compare subplots, when you're doing subplotting to compare data set. Here you see that they are all shifted in different direction. The same can be done for share Y, and we want them to be row specific again. Then you see that they are not at all the same distribution. If we want to put if we want to put label for the axis, we saw previously that we would use X label. When you're using subplot, you must use the set argument in front. So set X label to be first component in our case. I'm going to do the same thing for the Y label. It's going to be second component. If you want to set a title, set title. In this case, the title we're going to put, it's let's say we do distribution with the data set we're analyzing, and then we'll compute. There we go. Now, if we go to the second row, we want to do plot a distribution of the first component with a line for the mean. In our case, in this case here, the row is going to be equal to 1. And then again, we're going to use a for loop where the column will be equal to C. We want to do a XR C. Right now we're using the hist function. The X for the hist function is going to be, we're doing the first component, so it's going to be X scatter C. We want to use the hist type step field. Again, the color. Yes.
So the reason you use C equal I, it's because you don't really need it just to say it's a column.
Yes, exactly. I could do it here.
Okay.
It's just to have C as column.
Yeah. Mm-hmm.
I have my histogram here again. And again, the values are on the y-axis are shared for all of the all of the how do we call it? All of the subplots. Sorry. If we want to add the mean value, again, RC. We use the AX. We want to do a vertical line. We want to calculate the mean. It's going to be the mean of X. Line style. I'm going to do it pretty simple. I'm going to keep the same color. Sometimes it's fun to put the actual values that you're analyzing. So we could say that it's going to be 0.2f. So I'm going to give this value here. And the 0.2f means that we only want 2 significant values. And then if I come here and do PLT legend, it's going to tell me that there's no handles with label found to put in legend. But I did say what I want my label to be. If you use PLT legend, it's going to assume that you're only the last PLT used was the last subplot of your figure. So if you want to have a legend in that is specific to your subplot, you need to define it within your subplot like this. I like to put frame on 2, and yeah. If I do like this, you should have the mean values for all of your histogram distribution here. The color is not the best choice, so let's put it black. Like that. So you have the mean value here, and it's when you, by default, your legend's going to try to be put in the best place, so it does not overlap with any other element of your subplot. So this is why it's on the left side of the graph here, and then here it's on the right side. So that's pretty nice. For a third row, we want to do pretty much the same thing, except that now we want it to be on a third row, and we want to have the second component, so the y scatter and y scatter. Here, if I plot my histogram, my computer is quite slow. I have, again, here, the various distributions. So it can be very useful to look at this kind of subplotting. If you want to compare like histogram distribution or the whiteness of a distribution, I would recommend to switch it. So meaning that each column is specific to a representation rather than a data set. So in this case, here we have for the first column, the data set in a scatter plot. And then we have all the distribution for the first component on the second column. And then you can see that there's a shift, for example, in the mean of the red data set compared to the mean of the blue data set. So, yep, that's pretty much it for the subplots. Do you have any questions? Do you like subplots? I love subplots. It's very useful if you,
if I want to align the mean value for all the graphs in one side, like the mean value we saw, like it chooses at the best places.
Here.
Yeah.
The legend.
The legend.
Yeah. You want the legend to be in the exact same spot for every subplot.
Yeah.
You can use the lock argument.
Oh yeah.
And instead of using best, you could do upper right.
Right. Yeah.
Or down left or center. And I only did it for the last row. So on the last row, it's going to be on the upper right side, no matter if it's the best or not the best way to do it. If you're doing PCA analysis, this kind of subplotting approach is quite nice if you have a lot of principal component. So instead of doing like the 3D graph, which can be not that easy to plot and not that easy to visualize in 2D, you can have a n by n matrix where n is the number of components you want to consider, and then you can do a bunch of pairwise analysis and fill them, and then you can see for which component there seems to be the most separation of your data set. So that's very interesting for this kind of representation. And one thing I did not specify is I like to use the type layout function. So it's a magic function where it's going to add some padding to your graph, so that if you have a label for it sends a while label that is bigger than expected, then it's not going to go on the graph that it's on its left. If I don't use it, sometimes it can be cramped, because I defined we defined the style that we wanted the font size to be set to 15, which is quite big for this kind of representation. So instead, you want to play with the padding manually, which I don't want to do. I like to use the PLT type layout, but then if you're very extreme in your labeling, then you might have to change the fig size here. But it's a small downside for all of the greatness it does. And then this example. Any question with